Uh, Good day to all the lecturers. Today me, Ramanesha, metric number 2230182,
And I am Rajizam Al-Bakri, 2230181.
are going to be presenting the engineering lab report. Next slide. So first we'll go to the overview of this lab report. First we have introduction. Next, safety awareness. Thirdly, we have design and planning. Fourth, we have final results. And lastly, we will go to the conclusion. Next slide. So let's start with the introduction, and so we'll go to the purpose of the report first. So the first purpose is to obtain the current which one to use in wiring. The next one is to differentiate between ring and radial circuit, and third is to demonstrate the concept of current flow in wiring. Okay, now let's go to the single phase wiring and its importance. Next slide. So single phase wiring is the most common type of electrical wiring used in residential, commercial, and industrial buildings in Malaysia. It employs an alternating current source to provide power to various electrical devices and appliances. So the first importance of single phase wiring is simplicity and cost effectiveness. Single phase wiring is relatively simple to install and maintain, requiring fewer wires and components compared to other wiring methods. Thirdly is compatibility. Single phase wiring is compatible with the vast majority of electrical devices and appliances designed for use with 230 volts AC power. This compatibility simplifies the selection and installation of electrical equipment, ensuring that the devices can be easily connected to the electrical grid. Thirdly, we have reliability. Single-phase wiring is generally considered reliable and efficient in transmitting electrical power to various loads. Proper installation and maintenance provide practices can ensure a long lifespan and minimize the risk of electrical failures. And lastly, we have safety. Single-phase wiring is considered safe because when installed and maintained correctly, single-phase wiring can provide a safe and reliable means of distributing electricity. Compliance with electrical safety standards and regulations help prevent electrical hazards and accidents. Next slide. Now we'll go through the scope of the report. First off, a wiring lab report should have introduction, experimental setup, methods, results, discussion, and conclusion. Next slide. So now I will talk about the specific tasks covered in this lab report. First, you have hands-on one, the distribution box installation and surface wiring. So the first picture shows a schematic diagram of a main circuit. The distribution of a main circuit is actually a distribution box. So the distribution box is a metal or plastic enclosure that houses the electrical components that distribute to the power to the different circuits in a building. The main components of a distribution box are circuit breakers, which protect the circuits from overload, and the bus bars, which distribute the power to different circuits. In this picture, the distribution box is shown with two circuits, one for the lighting and one for the power outlets. The lighting circuit is connected to the main switch, which is used to turn the lights on and off. The power outlet circuit is connected to the RCCB, which is called residual current circuit breaker. It protects the circuit from ground faults. And the picture next to it is a schematic diagram of a lamp circuit. In the lamp circuit, the two-way switches are connected to the live terminal of the distribution board. The two-way switches are then connected to the lamp holders, and the lamp holders are connected to the neutral terminal of the distribution board. So how is this lamp circuit installed? So it is installed using a installation method called surface wiring. So it's a type of electrical wiring that is installed on the surface of a wall or ceiling. So surface wiring is actually used in older homes that do not have concealed wiring. It can be installed using a variety of materials, including plastic, metal, and wood. Okay. Next slide. So now we're talking about hands-on to conduit wiring. So in this schematic diagram shows a power socket with the outlet with the ring and radial circuit. A radial circuit is a type of electrical wiring in which the current flows from a central point to each of the individual sockets. In this case, the central point is the fuse box, and the individual sockets are the power sockets. A ring circuit, on the other hand, is a type of electrical wiring in which the current flows in a loop from one socket to the next. In this case, the loop starts at the fuse box, goes to each of the power sockets, and then back to the fuse box. Next slide. So now lastly, hands-on 3, which is mini trunking wiring. So in this given this schematic diagram of ceiling fan and a one-way switch, there are two switches, a one-way switch and a two-way switch. The two-way switch is used to control the light. The one-way switch is used to control the light, while the two-way switch is used to control the fan. The light connected to the one-way switch. The light is connected to the one-way switch, and the fan is connected to the two-way switch. Mini trunking wiring is a versatile and flexible wiring system that can be used in a variety of applications. It is ideal for use in areas where there is a good need for a high degree of flexibility, such as in offices or retail stores. Okay, next slide. Okay, now I will mention the relevance of Suruhanjaya Tenaga. In Malaysia, safety and reliability of electrical wiring is overseen by the Suruhanjaya Tenaga, also known as the Energy Commission, which is established in 1972. The Suruhanjaya Tenaga plays a crucial role in safeguarding the public from electrical hazards and promoting best practices in electrical industry. So, what is its specific relevance to wiring? Next slide. So first off, we can see Suruhanjaya Tenaga's regulations cover various aspects such as cable selection and sizing. The Suruhanjaya Tenaga specify the types of size and sizes of cables that must be used for different applications based on factors like current carrying capacity, voltage drop, and circuit protection. Next, we have wiring methods and practices. The regulations stipulate safe and proper methods for installing and routing wires, ensuring they are protected from mechanical damage and environmental factors. Thirdly, is earthing and bonding. Proper earthing and bonding are crucial for safety, and the Suruhanjaya Tenaga regulations mandate specific requirements for these aspects in electrical installations. Lastly, we have testing and certification. Uh, Completed electrical installations must undergo testing and certification by authorized personnel to ensure compliance with the regulations and safety standards. And now my friend will be presenting the safety awareness.
Okay, this is safety awareness. The first one is I will talk about Suruhanjaya Tenaga. Safety in electrical installation is to prevent accidents and ensure the reliability of electrical systems. Suruhanjaya Tenaga's safety guidelines provide a framework for the design, installation, and maintenance of electrical installation in Malaysia. These guidelines are critical in minimizing the risk of electrical hazards such as electrical shocks, fires, and equipment failures. By following Suruhanjaya Tenaga safety standard, practitioners can ensure that installation meets regulatory requirements. Compliance with this guideline not only protects the well-being of individuals but also contributes to the overall reliability of electrical systems. This promotes a secure environment, reducing the likelihood of electrical accidents and improving the efficiency of electrical system, thereby benefiting both the public and the industry. Okay, this is safety equipment and their purpose. The first one is multimeter. It is to determine the presence of voltage in circuits without direct current. The second one is insulated glove to protect your hands from electric shock when working on live electrical components. And finally is hard hats to protect against falling objects and head injuries during electrical installations. So, safety procedure follow. The first one is personal protective equipment, PPE. Please ensure all participated are wearing the appropriate PPE, including safety glasses, gloves, protective clothing, and safety footwear. They also ensure that the PPE is in good condition and fits properly. And then the second one is electrical safety. It verifies that all electrical equipment is properly grounded and in good working condition. And then it ensure that all electrical connections are secure and properly insulated. And finally is machinery and equipment safety. It verify that all machinery and equipment are properly maintained and inspected regularly. And then it ensure that all participants are trained in the safe operation and maintenance of the equipment they are using. So it will reducing and minimizing the risk when doing their installation. So Manish.
Okay, next we have design and planning. Next slide. So first we'll go through hands-on one and how we designed it. So first you can see the schematic diagram of a main circuit. So the main circuit is a wiring system that connects the electrical power source to the distribution board. The distribution board is a metal enclosure, houses the circuit breakers and fuses that protect the individual circuits in the home. The main circuit is typically wide with 4 mm square cable, and the branch circuits are typically wide with 2 mm square cable. Whereas the lamp circuit is a wiring system that connects the light switches from the to the light fixtures. The lamp circuit is typically wide with 1 mm square cable. So what are some important things that we should consider when wiring these systems? First is the size of the electrical load. Second is the voltage of the electrical supply. Third is the type of cable that will be used. Fourth is the location of the electrical outlets and the light switches. So now let's talk about how we design how to wire the main circuit. First step is the main switch is connected to the live terminal of the distribution board. Second, the neutral terminal of the distribution board is connected to the neutral terminal of the main switch. Third, the earth terminal of the distribution board is connected to the earth terminal of the main switch. And lastly, the brass circuits are connected to the distribution board. And lastly, we will talk about how to wire the lamp circuit. So first step is the two-way switches are connected to the live terminal of the distribution board. Second, the neutral terminal of the distribution board is connected to the neutral terminal of the two-way switches. Thirdly, the earth terminal of the distribution board is connected to the earth terminal of the two-way switches. And fourth, lastly, the light fixtures are connected to the two-way switches. Next one, we will move on to hands-on 2, which is conduit wiring. And radial and range circuits are shown in the diagram. A fuse connection unit FCU, often seen in the kitchen, receives power from the consumer unit. The FCU and a 30 ampere ring main unit are connected by a 2 mm square cable. The first socket outlet is connected to the RCD via a 2 mm square cable. At 1.5 mm square cable is used to connect the second socket outlet from the first socket outlet. A 1.5 mm square cable is used to connect the third socket outlet from the second socket outlet. A 1.5 mm square cable is used to connect the fourth socket outlet from the third socket outlet. To link the FCU back from the fourth socket outlet, use a 2.5 mm cable. The wire that powers the socket outlets in the ring main circuit, or 2.5 mm square, is utilized for this purpose. Radial or the cable that joins the socket outlets to one another uses the 1.5 mm square cable. So what should we consider when designing this? The kind of load that will be linked to the electrical system. Second, the separation between the consumer unit and the outlet that is farthest away. Third, the voltage drop that the circuit will experience. And now we move on to hands-on 3, which is mini trunking wiring. So the wiring diagram shows a connection of a ceiling fan and a one-way switch. The power comes in from the distribution board to the one-way switch. The switch is connected to the ceiling fan. The neutral wire is connected from the distribution board to the light, and the earth wire is connected from the distribution board to the earth point. So what is the design process for this wiring? So the first step is to determine the size of the cable to be used. The recommended size for the power socket outlet is 1.5 mm square. The second step is to cut the cable to the required length. Third step is to strip the ends of the cable. Fourth step is to connect the wires to the terminals on the one-way switch and ceiling fan. Fifth, connect the neutral wire to the neutral terminal on the distribution board. 6. Connect the earth wire to the earth terminal on the distribution board. 7. test the circuit to ensure that it's working properly. So next, we'll show you the choice of materials. Next slide. The items listed in this picture are mainly electrical components and tools required for electrical wiring. The choice of materials and equipment used for wiring is crucial to ensure safety and compliance with the Suruhanjaya Tenaga standard. Now we will move on to the final results.
Okay, this is our final results. This is a few moments when finishing our hands-on one to set up our distribution box. Then this is our Qfinity test result using multimeter. The next one is our moments when finishing our hands-on two. And this is what our Qfinity test result using also using multimeter. And the first one is for radial circuit of power circuit outlet, and the second one is ring circuit of power socket outlet. And finally, this is our moments when finishing our S13, and this is our Qfinity test result on ceiling fan circuit. And this one is one-way switch circuit for our lamp, for the lamp. And this is our result after finishing our all the hands-on. There are a few challenges we will face. The first one is multimeter malfunctions. The main challenge will be to ensure that the multimeter is properly configured to measure continuity. The multimeter should be set to the lowest resistance setting, and the probes should be properly connected to the circuit. If the multimeter is not properly configured, it may not be able to accurately measure the continuity of the circuit. Next is loose circuit. Another challenge will be to ensure that the circuit is properly connected. If the circuit is not properly connected, the multimeter may not be able to accurately measure the continuity of the circuit. And finally, it is important to be aware of the potential hazard of working with electricity. When working with electricity, it is important to take precautions to avoid electrical shock. These precautions are including wearing proper safety gear such as gloves, safety glasses, and the most important, we need to avoid contact with live wire.
Okay, now lastly we will go to the conclusion. Electrical installations in Malaysia must adhere to the Suruhanjaya Tenaga rules and safety aspects. This ensures the safety of installers and users. Additionally, individuals can develop their electrical skills, including circuit installation, understanding electrical theory, working with various wire types, and troubleshooting circuits. With a focus on safety, they can develop problem-solving abilities and practically apply critical thinking to resolve electrical challenges. Furthermore, there are opportunities for research and development related to Suruhanjaya Tenaga guidelines, such as applying cybersecurity, smart grids, renewable energy integration, and energy efficiency. And with that, our presentation for our lab report comes to an end. Hope you
Thank you.
enjoyed the presentation. Thank you.